You lift the shell from the edge of the fire. It is larger than your fist. The surface is blackened. Inside, a soft body glistens in the heat. You pull it free and eat it. To a modern viewer, this meal may look like a dare. To your ancestors, it could mean fat, protein, water, and one more night without hunger. The strangest foods in prehistory were rarely chosen because someone wanted to be adventurous. They were chosen because the world did not care what disgusted you. Your modern appetite is protected by farms, refrigeration, roads, markets, and thousands of years of food traditions. You can reject a meal because it looks unpleasant. Your ancestors often faced a different question: can this keep you alive? The answer created a menu far wider than roasted meat. Ancient humans cracked bones for hidden fat, cooked giant snails, dug bitter underground plants, collected shellfish, swallowed insects, and ate organs and sometimes processed human bodies. Some foods were emergency resources. Others were ordinary, valued meals that only seem strange because your culture stopped eating them. The first lesson is simple: strange is relative. Imagine standing beside an ancient lake around 780,000 years ago. Large freshwater fish move through the shallow water. You catch one, but you do not simply tear into it raw. You bring it near controlled heat. At Gesher Beno Yaakov in Israel, archaeologist Irit Zohar and a team including Nama Goran Inbar studied thousands of fish remains. The site preserved many throat teeth from large carp-like fish, but very few of the fragile bones you would expect from naturally dead fish. Many of those teeth were found near concentrations of burned flint. The researchers also examined how heat changed the structure of the teeth. Their results suggest the fish were exposed to relatively low cooking temperatures about 780,000 years ago. Cooking at lower heat is different from dropping food directly into flames. It suggests control. Why would that matter? Raw fish can be difficult to chew, digest, and preserve. Heat softens tissue and may reduce dangerous microbes and parasites. Cooking also allows more energy to be extracted with less work from your teeth and digestive system. Fish does not sound strange today, but picture eating a large freshwater fish before pottery, metal hooks, frying pans, or salt shakers existed. The meal depended on reading the lake, catching slippery prey, managing fire, and knowing when the flesh was ready. That was not a primitive accident, it was a technique. Now move away from the lake and follow a hunting group. The animal is dead. The meat is removed. The useful organs are taken. A modern person might see the remaining lower leg bones as waste. You see containers at Kizim Cave in Israel. Archaeologist Ruth Blasco and her colleagues studied deer limb bones from a period between roughly 420,000 and 200,000 years ago. The bones carried marks suggesting that skin had been left around them and removed only later, after it had dried. Why leave skin on a bone? Because the bone itself could protect the marrow inside. Marrow is the soft, fatty tissue in the hollow center of certain bones. It is dense in energy, and energy becomes extremely valuable when lean meat is abundant but fat is scarce. Eating too much lean protein without enough fat or carbohydrate can make your body sick. The researchers tested how long marrow could remain useful inside skin-covered deer bones. Under their experimental conditions, the fat degraded slowly for as long as 9 weeks. The ancient bones showed damage patterns consistent with delayed cracking and consumption. Your ancestor may have carried a leg bone like a sealed package. Weeks after the hunt, you place it on a stone. You strike it with another rock. The shaft breaks. A pale, greasy substance appears inside. You scoop it out with your fingers. Does that sound disgusting? Your body may disagree. Fat delivers concentrated energy, supports the brain, helps absorb certain vitamins, and can make an otherwise dangerously lean diet more balanced. In a world without bottles or cans, a bone could become natural food storage. The object that looks like rubbish becomes a prehistoric pantry. But marrow was not the only hidden resource. After breaking large bones, ancient people could smash the fragments even smaller and heat them in water or wet containers. Fat trapped within the spongy bone could rise to the surface and be collected. Archaeologists call this bone grease rendering. Rendering simply means using heat to separate fat from tissue. It is slow work. The bones must be crushed, fuel must be gathered, water must be managed. The reward is a layer of valuable fat from something predators and careless hunters might leave behind. Why work so hard for grease? Because survival often depends on extracting the last useful calories from an animal. A successful hunt can still leave you hungry if most of the animal is lean. Your ancestors were not only meat eaters, they were fat seekers. The next meal is easier to collect but harder for many modern viewers to imagine. You search beneath leaves after rain. A shell moves slowly across the ground. It belongs to a giant African land snail. You pick it up at Border Cave in southern Africa. Archaeologists Maureen Wojciechak, Lucinda Backwell, Francesco Derrico, and Lynn Wadley investigated fragments from large land snail shells. Experiments showed that heating modern shells produced color changes and structural damage similar to the ancient fragments. The evidence suggests giant snails were brought to the cave, roasted and eaten from about 170,000 years ago. The practice became especially common during later occupations of the site. Why carry snails home? They do not run. They do not fight. They can be collected by children, older adults, injured people, or anyone who cannot join a dangerous hunt. Their bodies provide nutrients and moisture, while their shells make them easy to transport alive. A snail is also a shareable food. You can bring several back to camp and roast them later. Someone who stayed near the shelter can eat. Someone recovering from illness can eat. A child can eat. The strange meal reveals something larger than hunger. It reveals care. The same cave preserved another food that would be nearly invisible without careful archaeology. Underground plant organs were roasted in the ashes. A rhizome is a thick underground plant stem that stores energy, often in the form of starch. Starch is a carbohydrate made from long chains of sugar molecules. Your body can break it down and use it as fuel. At Border Cave, Lynn Wadley and her colleagues identified charred remains of edible hypoxis rhizomes dating to around 170,000 years ago. The plants could be gathered across a wide region and carried back to camp. Roasting would soften them and make their stored carbohydrates easier to eat. You might imagine prehistoric survival as a steak diet. The ashes tell another story. At Clayse's River Cave in South Africa, Cynthia Larby and her colleagues found evidence of cooked starchy plant tissues in ancient hearths dating back roughly 120,000 years. The fragments showed that plant foods were repeatedly brought to fire and prepared. Roots and underground stems can look unpromising. Some are fibrous, some are bitter. Some contain compounds that irritate your mouth or interfere with digestion. Knowledge transforms them. You must know where the plant grows. You must recognize it when the visible leaves are small or absent. You must dig without destroying the edible section. Then you must roast it for the correct amount of time. A forgotten root may look like dirt to an experienced gatherer. It is stored sunlight. What about insects? Direct evidence is difficult because insect bodies rarely survive for hundreds of thousands of years. But primates eat insects. Many recent foraging societies collect them, and ancient tools may sometimes have been used to reach termites or other small prey. Insects can provide fat, protein, and micronutrients in a small package. Termites are especially valuable because a colony contains thousands of individuals in one place. You do not chase them across the landscape. You locate the mound, you use a stick or break open part of the structure. Suddenly, tiny moving bodies become a concentrated food source. Would you call that desperate? A handful of insects can be more reliable than a large animal that escapes. They require different knowledge, different tools, and often less rich. The modern disgust response hides the basic calculation: small food is still food. Coastal environments added another collection of creatures that could look alien on a plate. Shellfish cling to rocks or hide beneath sand. Crabs defend themselves with claws. Sea urchins are covered in spines. Seaweed feels wet, slippery, and almost inedible before you learn which kinds are safe. Yet coastal foods can deliver protein, fat, minerals, and other nutrients. The challenge is timing. A shoreline changes with the tide. A productive rock pool can become dangerous when water returns. Shellfish may also become toxic during certain natural algal blooms. Your ancestors needed a mental calendar of coast, moon, season, weather, and species. A strange food without knowledge can kill you. A strange food with knowledge can support an entire community. Organs created another category of valuable meals. The liver, heart, kidneys, tongue, stomach, brain, and blood of an animal may seem less appealing than a clean piece of muscle. But muscle meat is not automatically the richest part. Organs contain concentrated nutrients. Your ancestors often had strong reasons to eat them quickly. Organs spoil faster than many muscles. They are also difficult to transport. A hunting party might consume parts of the animal at the kill site before carrying meat back to camp. Picture the scene. The animal lies on the ground. Stone flakes open the body. Steam rises in cold air. The liver is removed while it is still warm. Nothing is labeled. Nothing is wrapped. Nothing is separated from the reality that food was once alive. Modern meat usually arrives after blood, skin, bone, face, and organs have been removed. This makes your meal psychologically easier. Ancient food demanded a direct relationship with anatomy. That relationship reached its darkest edge in cannibalism. At several prehistoric sites, human bones show cut marks, breakage, and other modifications consistent with bodies being processed. At Goyet Cave in Belgium, Hélène Rougier and her colleagues reported Neanderthal remains with evidence of butchery, marrow extraction, and even the use of some human bone fragments as tools. At Goff's Cave in Britain, Sylvia Bello and other researchers studied human remains associated with cannibalistic processing and skulls shaped into cups. But caution is essential. Not every cut human bone proves someone was eaten. Bodies can be cut during funerary rituals, cleaned after decomposition, moved, or treated symbolically. Even when consumption occurred, hunger may not have been the only reason. Violence, ritual, identity, and treatment of enemies or relatives may also have mattered. So did ancient humans eat people to survive? Sometimes nutritional motives may have been involved. In other cases, the meaning was probably more complicated. Archaeology rarely gives you the final conversation around the fire. It gives you marks on bone. Cannibalism is the most shocking item on the prehistoric menu, but it may teach the least about ordinary daily eating. Snails, roots, marrow, fish, insects, shellfish, and organs mattered far more often. The real surprise is not that your ancestors ate strange things. The real surprise is how little they wasted. They read landscapes as menus. A lake offered fish. A broken bone offered stored fat. A wet forest floor offered snails. Ashes softened roots. A shoreline exposed shellfish for a few hours. Even a termite mound could become a food reserve. None of this was random. Each food required a chain of knowledge. You needed to know what was safe, where it appeared, when it was available, how to collect it, how to process it, who could eat it, and how long it could be stored. A mistake might cause poisoning, injury, wasted effort, or death. That knowledge was carried by people. A child watched an adult crack a bone. Someone remembered which root needed longer roasting. A skilled gatherer recognized the season for snails. A storyteller warned the group about a dangerous shore. Food was not only calories, it was memory. Modern abundance encourages you to confuse preference with possibility. You can build an identity around foods you refuse. You can describe an animal part as waste because your supermarket does not sell it. Your ancestors could not afford that illusion. They survived not by loving every meal, but by learning where nourishment could hide. Inside a bone, beneath the soil, behind a shell, under a stone. Within a creature that moved too slowly, looked too strange, or seemed too small to matter. You began beside a fire, holding a blackened shell. Now the meal looks different. It is not a dare. It is a lesson your ancestors understood for hundreds of thousands of years. The strangest food is often only food you have forgotten how to see.